that'll stream on any variety of devices, and I'll post the links to that on our course webpage on MU Online. So let's go over some preliminary stuff. It is conceivable that we could finish early today, it being the first day of class and all. Here's just a brief outline of what we're going to be going over. We're going to just address some basic course mechanics. I'll hand out the syllabus. And then we're going to talk about the tools that engineers use to solve problems. You know, obviously, you're here because you want to be an engineer, and it's a licensed profession that is really important because of especially in the case of civil engineering, the good it can do for society, or when civil engineering is done poorly, the negative consequences are pretty dramatic as well. And then, believe it or not, on the first day of class, I'm going to give you a homework assignment. So, homework 0 kind of implies that it's not going to be a very difficult one. Before we get going, though, I asked you to log into the computer just so that it's ready when we need to get there. What I'd ask now, though, is that you switch off the monitor just so that it's not a distraction as we're going through some of these slides. And another thing is, if your mobile phone is out, put it so that it's not in view. And I'll talk more about that when we go through the syllabus. But not only should you not be using it, but it should not even be visible, which I know may be uncomfortable for some people. But, all right. So screens off, mobile phones put away. My name is Dr. Isaac Waite. I've been here at Marshall since 2009. I earned my PhD from Purdue University in 2005. And my areas of expertise, when I'm not teaching freshman level courses like this, I focus mainly on water resources engineering, which includes things like sizing water pipes that go under the roads to deliver drinking water. Water resources engineering also includes hydrology, which is an understanding of the water cycle, and trying to figure out, for instance, when it rains, how much runoff will there be, and when will the runoff arrive to a certain point. And just right literally outside this window, we can see the Ohio River, and you know, Huntington has had sort of a mixed relationship with the Ohio River over the years. It's part of the reason why Huntington is here is because of the river, and it flattened out what used to be hilly areas to make room for the city. And it's also, Huntington is one of the largest inland waterway ports in the entire United States when you go by the tonnage of freight that comes in and out of Huntington. But then also it can do damage when there's floods. And so that's part of water resources engineering. And just as an illustration, here's a picture of a dam. And so when you make it easily through your freshman and sophomore courses, and we meet up again for your junior level classes, you'll take, from me, fluid mechanics and hydraulic engineering. And then as an elective, there's hydrologic engineering, which is more about hydrology and the water cycle. But this picture is all about dams, and it also has a tie-in to electricity generation, as hydropower is an important source of energy in a lot of the United States. The other image, anybody know what this is that we're looking at here? It's an aerial photo, but what is it? Hint, it's not swimming pools. Exactly, it's a water treatment plant, yeah. The circular pools are clarifiers, and you can see that the water appears to be very glassy and calm in those clarifiers because the point of those is for particles in water to be settling downward. And actually, water treatment and wastewater treatment have a lot of parallels, whether you're purifying river water so that people can drink it, or whether you are purifying sewage so that you can put it back out into the river. You have to settle solids out of solution, and that's what a clarifier does. And then these other rectangular pools may be chlorine contact basins in the case of a drinking water treatment plant where you're trying to kill any pathogens that are in the water. And then we can tell that this is actually a wastewater treatment plant because there's a lot of air being added to these pools, and that's for activated sludge. One of the interesting things we do as civil engineers is we actually harness the power of bacteria to purify the water. And so we provide them with loads and loads of oxygen, and then they'll break down the sewage water into something that's safe to discharge into the river. So it's really a fascinating subject. I teach some undergraduate classes related to it as well as some graduate courses, but that's water resources engineering and environmental engineering in a nutshell. Any questions so far? Well, that's academically me, and it's got my office location, phone, and email. That's also on the syllabus, as well as my office hours. But I wanted to let you know a little bit about like my personal background, and I'm going to get that same information from you in Homework 0, which is basically all about me asking you to tell me about yourself and how you ended up in engineering and what are your goals for the semester. So I love to travel, and last year I was living in the United Arab Emirates. I was on sabbatical leave, which is something that professors can do every 7 years, is they can take a break from their home university and do something else. And a lot of people may take that time to write a book or to go someplace new and do research, and that's what I was doing. I was doing research and teaching courses in Dubai. And I think most people here have heard of Dubai and seen like TV shows about the world's tallest building, the Burj Khalifa, or the offshore islands, the Palm, that have been manufactured. And this is a picture that I took when I went for a jog out in the desert. And I think it's just a really pretty contrast to West Virginia. And the research that I was doing there is actually related to rainfall, believe it or not. Looking at this picture, you'd never think that it ever rains in a desert environment like the UAE, but it does. And when it rains, it really rains hard. And big floods will come through areas, very destructive floods. And so I was doing some research related to the timing of how long from when it begins raining to when the peak flow will arrive at a certain spot. And it's kind of an interesting contrast because I've done that same research here in West Virginia, where I've set up stream gauges at different locations and rain gauges, and then you have a very precise clock that measures when the rain begins, how much intensity there is at a certain spot, and then you look at, by the depth of the river, when that flow arrives, you can correlate it to some calculations that try and estimate the time of concentration, as it's called. And here in West Virginia, we've got really heavy tree cover, a lot of leaves on the ground. They call that forest litter. And so that slows down how quickly the flash flood arrives compared to a place like this where there's nothing to slow down the water once it arrives on the ground surface. And so that's a little bit about where I was last year, and I love to travel. In addition to visiting the UAE, along the way I visited a lot of other countries as well. This picture I took in Reykjavik, Iceland, which is a really beautiful place that kind of blew my mind. This photo was taken at 2 a.m. And so it's still, broad daylight in Iceland at 2 a.m. Just because they have such a far northern latitude. And it was a relief to be somewhere cool after spending a long time in the UAE where it got pretty warm. This picture is just a side trip that I took. I had a long weekend, and so I went to Armenia, of all places, just because I found a cheap airfare to Armenia and a nonstop flight. So I said, I've never really been to Armenia. I've never thought of Armenia, but why not go? And I'll tell you what, the food there was about the best I've ever eaten, and cheap too. I went to a really nice, fancy restaurant, and I had no idea what to expect as far as the quality of the food or how much it would be. But I didn't scrimp. I just thought, I'm just going to get everything. I got the appetizer, main course, actually a couple of main courses, an extra salad, bread, some drinks, dessert. When I walked out of there, it was like $7.50. I couldn't believe it. So if you travel abroad, sometimes you have a much better value proposition than, say, like Orlando, which is where I was over this past spring break, and it's just a horrible waste of money, and no one should ever go to Orlando. It's like the worst place on earth, all right? But we all go because we feel guilty. We've got to take our kids to Orlando. All right, and this is a church that I went to in Bulgaria, another place that was just sort of like on a whim. I noticed a cheap flight from Dubai to Bulgaria. It's like an 8-hour flight each way, but it was $200 round trip. I mean, that's less than they charge to go from Charleston to Washington, D.C., which is like a 40-minute flight. But I just said, let's go to Bulgaria. And so we did. And it was awesome. It was really cool. So I encourage you. One of the, soapboxes I'll get on occasionally is encouraging students to broaden your horizons and don't feel tied to any one place, because sometimes your best opportunities in life may be someplace you never thought of visiting or someplace you never thought of living. One other thing I like doing is hunting. I like deer hunting. This is a picture from a couple years ago. This year I just got a doe. Hopefully everyone here who hunts had a nice hunting season. When hunting season is over, like in January, I'll tap the trees on my property, and so here I'm collecting the sap from the maple trees, and then I boil that down and turn it into maple syrup. And it's kind of good exercise to get out and every night collect the jugs, and then you put them on a fire and evaporate it. It's very labor intensive, and it makes you appreciate how little sugar you should actually be eating in your diet. If you think about, like, if you're getting your sugars from nature and how much work it is to extract those sugars, it gives you an idea of how scarce it's kind of intended to be in your diet. I love running. This is a picture taken of me at the Boston Marathon, which I did in 2014. That's the year after the bombings there. And it was really an overwhelming experience, like so many people cheering, and man, just a really big event. I loved it. And I also like trail running. There's some gorgeous trails here in West Virginia and a really good trail running scene. If anybody's got spare time, you know, like between homework assignments or something, there's some great trails. And this race I ran out in California. It's called the Western States Endurance Run. And it's a 100-mile race that starts up by Lake Tahoe and goes through the mountains and finishes in near Sacramento. And it's really, and like Boston, kind of a really great event and tons of cool support. So I like the outdoors, but I like engineering too. So let's talk about the course. Grading is going to be on the basis of the percentages that are shown on the screen there. 20% of your grade can be earned just by showing up and participating. And so by participating, that means, for example, not fidgeting with your phone, staying on task when we're doing in-class exercise, paying attention during the lecture, and so on. 30% of the grade is the homework assignments, and the way that the course is structured, that there's enough flexible time during our class meetings that a lot of students will be able to complete the homeworks during the class meetings. Not all, and not all of the assignments will be that way, but many of them are that way. And so if you think about it that way, between the attendance and the homework, which you can complete oftentimes in this classroom, you get half of the credit for the course just in the 2 meetings a week that we've got here in this room. And then the remainder of the credit is on the basis of 2 exams. They're not comprehensive exams. They're each covering the material that's covered prior to the exam itself. And so we have one about halfway through, and then exam 2 is during finals a week. Any questions about that? All right. You may have already noticed that there's no book for the course, so we're saving you money, right? The calculator that you need for the course is pretty inexpensive, the Casio FX115 ES Plus. And I think that's available at the bookstore, at Walmart, and each of the computers in here have been loaded with an emulator of the calculator, but you'll need to have this calculator after we talk about this one. And the reason why it's this particular calculator is there's a small list of calculators that are approved for use on the Fundamentals of Engineering exam, which is the first licensing hoop that you have to jump through to become an engineer in training, which is kind of like a licensing designation. So there's only 4 or 5 calculators that are approved for use on that, and we figure that giving you an early start of exposure to this one will give you kind of a leg up during the test. Also in here, installed is Microsoft Excel and MATLAB. You can get Microsoft Excel through the university, I think for free or for very cheap, and install that on your personal computer. MATLAB, on the other hand, is only available, as far as I know, here in this classroom. We don't have very many licenses available, and students can't install it for free. And so that's part of the reason why the homeworks are designed so that you can do it here in the classroom and during our class time. And then for reasons of portability, you can either use your network drive, the V drive as it's called, that you can access here on this computer. But if you want to be able to take your files back and forth more easily, then a flash drive might be a worthy investment if you don't already have one. All right, please feel free to jump in if you've got any questions. So here's a little bit of information about the homework assignments. I'll mention them during our lecture, and the intention of the homework assignments is to correspond with the topics that we're talking about the lecture and to smooth you in towards the exams so that you're ready for the exams and there's no surprises. Usually you'll have about 1 week to complete them once they're assigned. There's a little bit of an exception. The assignment I'm giving you today, homework 0, is due on Friday of the same week. And homework number 1, which is supposed to be assigned on Thursday, I'm going to give you a paper copy of that today because our lecture on Thursday is going to be electronic. I'll be out of town, and I'm working on the Fundamentals of Engineering exam. I'm on a committee that actually writes the test, and so I'll be down in Clemson, South Carolina working on that Thursday. So we won't have class on Thursday, but you will have a video that you'll need to watch. I'll send you the link to that. So we'll be having, it's called an asynchronous course, meaning asynchronous lecture, meaning not during our normal scheduled time. I mean, you can watch it at 11 if you prefer, but all right. This is very important. Late homework is not accepted. If you have a valid university-approved excuse, then you could submit homework late within a narrow range of acceptable dates. But besides that, late homework is not accepted, and I would prefer that you not ask to break the rules. You know, if you just miss the assignment, just take your lumps and you get a 0 on it. And the reason for that is that that's going to be the case in most of the other courses that you have in the engineering department, and so we're trying to just get students in the engineering mindset in this course. We want to give you not only the tools to be an engineer, but also the thought process, sort of like the discipline and the solution formatting structure, just all of the things that you'll need to have and know and be to be a successful engineer. As I was mentioning before, we've got 2 exams, and we will have reviews prior to the exam to kind of bring everything together as far as the concepts go. And you will be able to have a formula sheet, so if that's a little bit of a comfort to you, then there's that. But you can't work out examples on the formula sheet. You can just have it like the equations themselves, and I'll collect those equation sheets with the exams. All right, well, let me give you a copy of the syllabus. Was anybody else in here during the earlier fire alarms? Are we supposed to just ignore it? Yeah. All right, well, that's a bad habit, but we'll do it. Okay, so everybody has a copy of the syllabus. I'm going to bring it up here on MU Online. You don't need to switch on the computers yet, but for anyone who may be watching remotely, here is our syllabus. You'll notice that it's got the information of a couple other instructors as well, Jeffrey Huffman, Gregory Michelson. This course is being offered, there's 3 sections of it, 3 different faculty members, but we're all using the same syllabus, we're using the same lecture notes, we're having the same assignments, and so you don't get off easy by being in one section versus another. It's all going to be the same, the grading basis and everything. So you'll notice here under my information, my office location, it's not in this building. My office is in the engineering lab building, which is the smaller building right next to us, and I'm in room 113. My office hours are Tuesday, Thursday from 2 to 3:30, and then Wednesday from 1 to 4. And if you're not able to visit with me during those times, of course, you can email me for an appointment, and sometimes I'm in the office and available outside of those times. Sometimes I have committee meetings or I'm in the middle of research, but I want to do whatever I can to help you out this semester, so please do not be shy about asking for help if you need some assistance on the homework or understanding the course material. All right, so there's a number of policies that you need to be aware of, and you can see from the list here, it's very lengthy: academic dishonesty, excused absence, computing services, and so on and so on. So at least once in your life, you should read through all of those policies. If you haven't already, there's the link to do it. Our course is an introduction on problem-solving techniques in engineering applications with an emphasis on accuracy. And sometimes students forget once they get beyond this course, the ideas of accuracy and how many significant digits need to be included in calculations. And so we're going to try and train and reinforce those ideas this semester. And the three main tools that we'll expose you to this semester are the approved calculator, spreadsheets, and MATLAB, which is a programming language that is used in engineering, especially in research. Okay, we'll skip over some of this stuff because you wouldn't be in here if you didn't already meet the prerequisites, for example. And here's the same information I told you before about the grading basis. Note the grading scale. There's the normal grades and the normal breakdowns for that. The objectives you can read later, but our attendance policy, I'll reiterate the fact that attendance is required. I'll be taking roll, and as it says here, if you arrive late, there goes the fire alarm. Hopefully it won't be for too long, right? If you arrive late to class, then that counts as half an absence. Talk only to participate in class discussions. Now this must be important because not only is it a big font, but it's underlined and bold. Cell phones and mobile communication devices should be turned off during class, and I add put away out of sight. And I actually had a student tell me about some research last semester that they found that just the sight of a phone is distracting because it reminds you that there's something better than what you're doing now. Like obviously sitting here in a lecture hall listening to a teacher isn't your number one place you'd want to be right now. Like you'd rather be at the beach, right? Or maybe you'd rather be at Universal Studios or in Armenia having a nice meal, right? So there's some place you'd rather be besides here, and the phone is just a reminder of that. It's like your gateway to someplace else. And so you're sort of like exercising discipline by putting it out of sight, and it helps you to focus on the now. So please make note of that, and I'll issue any reminders that may be needed. Another thing it says here in the bullet point is don't work on assignments for other classes because, you know, if you're doing that, you're not as focused on today's material as you ought to be. Any questions so far? That really is distracting, isn't it? Yeah. All right. Okay, communications. We're using MU Online, and so turn on your screens and log into MU Online. And it's possible maybe that some of you have never done that before. So if you go to the website, Marshall's homepage, this will be an exploring thing because I've never got to it straight from the homepage, but I assume it's possible. There we go. MU Online, right at the top. So go to MU Online, log into Blackboard, which is just another name for MU Online. And then your courses will come up. One of the courses that you see should be Engineering 111-203. Not working? Oh, taking its time? All right, well, it looks like for many of you it's loading the profile, which can be a lengthy process. So if you're in the middle of that, just watch on the screen here. So here's our course. You click on it, and there's not a lot of different options. You'll see homework assignments and the syllabus for now. Over here on the left side is my grades, and you can click there and get your grades at any time during the semester. I'm going to be updating the grading continuously, and your weighted average will be available there. A lot of instructors don't use the weighted average thing, but you can actually see like the factor of your attendance, homework, exams, and so on. So early in the semester, your average may jump all over the place initially because there won't be very many assignments early on. So don't panic early in the semester because, you know, neither of the exams will be in account at first. But I wanted to mention that. So if you click on homework assignments, you'll see homework 0 is already available. Right here, homework 0, intro. And so you can click on that, and there's some place for you to either upload a file or to write a text submission. Let me hand out homework 0 to you. The PDF of it's also available on MU Online. If you just click on the link, then it brings up homework 0. But I printed a paper copy for you. And you'll notice it's 3-hole punched. I'd encourage you to get a binder, a 3-ring binder for the course, just to hold on to all your papers. That'll really help you out a lot on the exams. If you have access to all the handouts and all your homework, if you stay organized, it'll pay big dividends. You know, you can get a good folder for just $2 or $3. So it's definitely worth your money. There we go. All right, so this homework 0 probably won't take you more than 15 minutes or so. You'll notice here it says upload to MU Online before 12 p.m. on Friday, January 13th. At 12 p.m., it vanishes, and you won't even see it anymore on MU Online. Like from the list of assignments, if we go back here to homework assignments, it's there now, but at 12:01 on Friday it won't be. So you won't be able to upload the assignment after that. So what you should do is just type your answers to these questions in Word, and then you can save the file and then upload the file here where it says browse my computer. And you know, if you've got it on your flash drive or your V drive or wherever, you just browse to that file location and upload it. Some of the assignments this semester will be submitted electronically like this, and some of them will be submitted on paper. This first one's electronic. Okay? So the other stuff that's here in the course content, generally I will have the links for the lecture recordings. I'll create a new folder for that that says lecture videos, and that's where you'll be able to go to the YouTube videos that, you know, it's a screen recording plus my voice for those videos. The syllabus is there in case you want to look at the schedule. One of the, we're still going over the syllabus, one of the things that's on here that's very valuable is it shows what we're doing every day. That's on page 5 and 6, the schedule for the semester. So you'll see that today's the course overview. Thursday of this week is Fundamentals Part 1, and that lecture is going to be online. Lecture 6, you'll notice where it says Makeup Day. That is a day where they're having a technical conference here on campus, and if you attend the technical conference, you'll get credit, attendance credit. You know, attend the conference during our class time. We'll talk more about that later as it comes up. Okay, so back to communications policy, which is where we were. MU Online/Blackboard. Here you've seen it. If you don't have access to MU Online, then you can go over to the library. The IT guys there can help you restore your password or give you access if something's fouled up. Then it's on the ground floor of the library that those IT people can help you. Also, emails are really important for you to be receiving. So if you don't yet have your email set up to go to your phone or wherever you access your email, set that up after class so that when I send you a message, you receive it. That's the most immediate way that I have to communicate with students, and so you need to check it every day at the least. All right, I want to point out here where it says the academic dishonesty policy. This semester I will encourage you to work with other students. It's a really good habit to, you know, be able to work in a team environment and collaborate with others and, you know, explain the things you know, or to learn from your peers, not just to learn from faculty members. That's great. I'll encourage it, but there are limits to what's considered healthy collaboration. For example, if there is an assignment and everyone, let's say 3 or 4 people, are sitting at a table and going every step through the assignment at the same speed, then probably what's happening is whoever naturally would be working the slowest is just writing down what the other people say. And they're not quite figuring things out at their own speed in the same way that they were if they would be working individually. And so it's sort of like robbing you of a learning opportunity if you are group working homework problems simultaneously. So it's okay to check final answers with other students, and like if one of you has a mistake, it's okay to discuss the particulars of that, but try and do your work independently. And I want to point out that incoming assignments will be screened for inappropriate collaboration. And the university has very strict policies against cheating. Students who engage in inappropriate collaboration may have a range of penalties assigned, everything from a 0 on the assignment in question up to being dismissed from the university. So it's really serious, and I'd encourage you to take it seriously. All right. For now, I think we're going to be done with the computers. We may come back to it. So just please switch off your monitors so that's not a distraction to you. Thanks. Okay. Any questions about the academic dishonesty policy? Let me go back to that here. Okay. There's going to be a pretty specific formatting guidelines for the assignments that you submit this semester. Now let's go over those, and I'll show you an example. You know, like wire-bound notebooks are really convenient and they're cheap, but you can't turn in your homework assignments on like a piece of paper that's been ripped out of a lined notebook paper. That's just not professional, and it wouldn't be considered acceptable in an engineering environment. And so we're going to train you to prepare solutions that another engineer could read and understand. And documentation of what you were thinking is really important in engineering, because you may work on a project, do a bunch of design work, and then move on to a different project, come back to the first one 10 months later or 10 years later, and suddenly be wondering, like, what were you thinking? How did you do a certain thing? And so having neat, consistently formatted solutions will be a good way for you to communicate with like your future self, and it will save you a lot of time on the long run if you can repeat a process that you've already done before in one place somewhere else. And so that's a little bit on the background of why we insist on neatness and a certain standardized procedure on submitting homework assignments. I think I've already mentioned that late homework assignments aren't allowed. They just aren't accepted. But here's what you need to know about like the formatting of homework assignments. It should be legible, clear, and written in a professional way. If it's sloppy or otherwise unprofessional, the assignment will receive at least a 10% deduction, and maybe more. Assignments should have a cover sheet with your name, course number, section number, instructor's name, assignment number, assignment date, and actual submission date. So let me show you what that cover sheet should look like. There's an example of it here on MU Online in the course content. Under the homework assignments folder, Dr. Michelson put this together. It's an example homework solution, and you'll notice that it's green. You may be wondering, let me dim the light so it's easier to see. You may be wondering why it's green. Is this easily visible from the back of the classroom? I'm not sure if I like these flat screen TVs. I liked it better when it was projectors because it was so much bigger. But anyways. All right, so it's got the name, the course, the section number, the assignment name and number, when it was assigned, and when it's due. This is a special kind of paper. It's called engineering computation paper. You can buy it on Amazon. You can buy it on eBay. I think it's in the bookstore. It might be available like at Office Depot or Staples or that kind of a place. But what it is, this special paper is it's lined with graph on the back, but you actually write on the front, so that when you take a photocopy of it, you don't see the individual squares, but the individual squares are there to help you to draw things to scale and to kind of make the drawing neat. So if you haven't used engineering computation paper before, I'd strongly encourage you to go and buy a pack of that. It's unfortunately more expensive than it ought to be. I think even when I was a student, it was like $5 for a sheet, a pack of 200 sheets. So it's kind of a rip-off, but it's worth it in the end. All right, so that's the cover sheet expectations. If you're not using engineering computation paper, at the very least, spiral-bound perforations must be removed or your assignment will be returned. If you're doing something on the computer, like when we have Excel assignments, you need to print it out so that it fits on a standard 8.5 by 11 page. And so you can't print out your work and have half of the assignment on one page and half on the other. I'm not going to do a jigsaw puzzle with homework assignments to try and figure out which rows match with which. And I'll show you how to make it so that it's easy to print the entire document just on one sheet if you're not already acquainted with how to do that. You should show all of your steps. And here is a formatting example of what we mean by show all of your steps. To show all of your steps on assignment, the first thing you'd do is you'd summarize what is the problem itself. And so you'd identify the problem statement. You'd pick out the given information, like any constants that you're given in the problem statement. It's very, very helpful when solving an engineering problem to draw a sketch, because sometimes just the process of doing a simple drawing like this will help you to visualize how to solve the problem in a way that you wouldn't have thought of if you didn't do the drawing. And so the diagram is something I really encourage my students in fluid mechanics and hydraulic engineering to do, because 9 times out of 10, if you do the sketch, you're going to figure out which equation to use and kind of get a jump start on what you need to do to solve the problem. If there are any assumptions, you should document those. List the governing equation, the one that you're going to use for substituting in the given information to solve for the answer. And you can see here the calculations include the units. This is another thing that I'm going to get on a soapbox really often and remind you that you should include the units with your calculations, because if you don't, it's really easy to make mistakes. Let's say that you had a test and they give some of the dimensions in inches and some of the dimensions in feet. Well, if you just wrote down the numbers without the dimensions and the units, then it's really easy to forget that you need to make the conversion. And that's something that pops up a lot on the FE exam, for example. That when you take that test to become a licensed engineer, there are a lot of pitfalls you have to watch out for, and many of them can be avoided if you include the units with your calculations. So at the end, the answer is boxed, clearly labeled as the answer, and has the appropriate units at the end, as well as the variable volume. So this is a problem that you could solve in a tiny little piece. If you were just saying 40 by 20 by 8 equals, what was it, 160? 181? I mean, you could do the multiplication in a really small way, but that's not the point. The point isn't to save paper when you're doing these calculations. The point is to be methodical and reproducible so that you could look at this and feel confident that the assumptions are correct, the main idea, the person knew what they were doing, and you can come back to any calculation that's documented this detailed in the future and very quickly understand what they did. All right, so this example is there on the course content, and there's another one as well. Let me show you example solution number 2. It's from Dr. Michelson's steel design course, if you want to get an idea of where you're headed someday for that. So this is a little bit more abbreviated because I think that it's already assumed what the problem statement is and so on. But you'll notice it's still, each row is very neat. It's easy to read. The units are included. The answer is boxed. So I'd encourage you to look back on these examples when you're preparing your own assignments. All right. We will skip over the examination policy and revisit that information when we get closer to the tests. But This table on page 4 of the course student learning outcomes, this is why you're taking the class, is to learn this information. And so we provide a table that shows like how you're going to learn it, how you're going to pick up each of these attributes, and then how you're going to be tested on it. And at the end of the semester, we'll ask you how you feel like you learned each one of these. And then we as instructors have to take certain questions from the tests and map them to these outcomes. And so like maybe question number 1 on the first exam is trying to find out whether students can effectively use a calculator. Question number 2 may be mapped to able to use a logical, well-organized solution methodology. And I'll assess whether you're just writing the numbers or whether you're following a step-by-step procedure that's reproducible, easy to follow, and so on. So those are the outcomes that sort of inform how we spend our time in the course, and I've already pointed out to you the lecture schedule. And so this lecture schedule was designed with the idea of we want to achieve certain outcomes by the end of the semester, here's how we're going to do it, and this is the when. So homework 0 I've already handed out, and that's due on Friday of this week. The rest of the assignments are shown here, when they're going to be assigned and when they're due, and I'll give you reminders throughout the semester. But are there any questions related to the syllabus? All right. So here's just a review of what I showed you in that example about presenting your calculations, the components of a problem presentation. You'll repeat what is the problem statement, or at the very least summarize what you're trying to find. Step 2, you'll put together a diagram and label what's on the diagram, maybe length, width, height, or a sketch that shows the pieces of it. You'll list the assumptions that are being used in order to solve it, a list of the equations and principles, the calculations, including the units in the calculations and with the answer, and then an answer check, like a sanity check or a reasonableness check. Let me show you what that looks like. If we go back to the first one again. Sometimes you can very easily make a mistake somewhere on your assignment, and so if you double check to see whether it makes any sense, here was our answer. But beyond the answer, what this example shows is, let's just say that we think of it another way. How many feet it is, and so we did 181 cubic meters. We don't think in meters as often as we think in feet here in the U.S. since we use the traditional unit system. And so the sanity check is just, well, what if we converted from meters to feet, and then we found out about how much it would be that way. And so, 8,000 cubic feet is approximately 200 cubic meters, and so the calculations we did before when we found the exact value was 181 cubic meters, that seems like it's in the realm of possibility, because when we did the similar thing in traditional units, it was about that. So there are different ways that you can double check your work to make sure that it's reasonable. So think about money calculations. Like if you're doing calculations and I ask you something related to how much money will you make in a year if you get paid $10 an hour and you work 40 hours a week and take 3 weeks of vacation. So you do your calculations and it turns out to be $1.5 million. Well, probably that's not right. There's a mistake somewhere. It's not reasonable. Even if your calculations show that, you have to sort of double check to see if the range that your answer comes in at is even in the realm of possibility. Any questions? Sometimes it's just a matter of common sense. Sometimes you are reworking the problem in a different unit system, like the last example did. Or sometimes you may just do a ballpark estimate, like an order of magnitude, where if you wanted to find out how much, back to the idea of money, if you wanted to find out how much money you could earn during a certain job, you could just say there's about 2,000 hours, 2,000 working hours in a year, roughly speaking, if you're full-time. And so you multiply the 2,000 hours by the hourly wage, and then that would tell you what the annual salary is. And so that's just an idea of an order of magnitude estimate. Okay, so tools. One of the most important tools that an engineer has available is their judgment. And this comes over time as you gain experience. But even now, you have enough experience with the world, just how things work, the way that things fit together, that you can begin to rely on your judgment as a starting point for a lot of the problems that you'll need to solve in your courses. The calculator that you're going to be learning now, you may continue to use throughout your career. When I was a freshman, I purchased an HP calculator, and I still have that same HP calculator that I bought when I was a freshman back in 1993. That's when I started college, 1993, so I'm a lot older than you guys. But when I use any other calculator besides that one, it just feels awkward to me, like it's weird. The buttons are in the wrong place. So you'll sort of get like a fluency, and you'll be able to solve things really quickly over time. Software is only as good as the people that are using it. So, you know, design software is really powerful, but you have to understand sort of the fundamentals that are behind the design software, whether it's environmental software, structural, or anything else. And so that's kind of what we're going to be doing in this class, is starting with a calculator, doing problem solving, and then showing you using Excel how much easier some of those same calculations can be. You know, you can automate repetition with Excel in a really important way. Many of you have probably done graphs before with Excel, and that's useful, but the real power of Excel is working with large data sets and having it do things over and over again that you wouldn't want to have to do by hand. And then programming will automate things even further and speed up calculation possibilities. So what responsibility does an engineer have when using these tools? Well, one of the responsibilities is to know their limitations so that you don't use a tool outside of an environment where it's meant to be used. And I've talked a little bit earlier today about hydrology, you know, the study of rainfall and runoff. And there's a lot of computer programming in hydrology, and unfortunately, people make a lot of mistakes where they will use, for example, like a rainfall tool that was developed for West Virginia, and then they'll apply that in Arizona. You know, and West Virginia and Arizona have wildly different rainfall patterns. And so you have to really understand how programs are intended before you can apply them. And that goes to all of these tools. All of the tools have limitations, and they have uses, and so you have to know what's the range of acceptable use when you apply them. And when people make mistakes, it can really be a problem. The picture that's shown here is an engineering disaster that occurred in Connecticut when there was a ballroom that had been poorly designed because, if I remember correctly, they didn't put in sort of like reasonableness checks. They had used computer analysis, didn't really understand the software and what its limitations were, didn't manually check the calculations, and so the roof failed, I think during a snowy period when there was a little bit more load on the roof, and I think there were some fatalities from that. And so it's kind of an illustration of using tools that can save you time, but then not applying them correctly. A similar thing happened to the Mars Climate Orbiter, and this was a really expensive project that had been designed by engineers who were in the United States, and of course we use the traditional unit system most of the time, you know, inches, miles, pounds of force, and so on. But there was a mix-up where one piece of the software was working in SI units. NASA, for the rest of the project, was working in, did I say SI? One was in traditional units, one was in SI, and so the forces were off by like a factor of 4, and so it crashed into the Mars. It crashed into Mars and was a complete loss. Millions of dollars down the tube because of a conversion error, a units conversion error, not paying attention to the details that would have been caught if someone had included the units in the calculations and done like some manual reasonableness check along the way. And here's another illustration of a structural failure. And there are a lot of different loads that get applied to a bridge or a building. There are loads that are called dead loads. For example, like the desks that are in here, they're not moving, and so it's considered a dead load. And then there are things called live loads, where it's people walking around, or in the case of vehicles going over a bridge, that's a load that's moving around, and there can be wind loads in addition to that, and other types of impact, like the vehicle not only is moving, but also maybe it's coming over a speed bump. And so more than just the vehicle weight will be applied to a roadway surface in the case of speed bumps. And so in this case, people just weren't thinking of all the possible forces that could be applied to a structure, and it resulted in a pretty spectacular failure. All right. So we are going to be finishing a bit early, like I mentioned we might, and let's review what's going to happen over the next couple of days. First of all, did everyone get a copy of Homework 0? When is this due? Friday at noon. You could solve it. You could do it in the next 15 minutes. We're finishing 20 minutes early. So you've got nowhere to be at least for the next 20 minutes. You could work on that right now if you'd like. So that's due on Friday. And I'm also going to be giving you homework number 1. I'm handing that out now. This assignment isn't due until January 19th. So you still have plenty of time. And in fact, I'd encourage you, don't begin this one yet. Start this after you watch the lecture for Thursday. I'm going to be emailing you and posting a lecture link on MU Online for Thursday's class. So don't come here on Thursday. I'll be down in Clemson, and our lecture will be online. But after you finish the lecture, you have a copy of the assignment in case you want to get an early start on that. Any questions before we finish? All right, this is going to be a great semester. We're going to love this class. It's going to be a lot of fun. It's going to be relaxed. We're not in a rush. So many classes, they're just pounding through the material as quick as they can, like jumping through the slides at a breakneck speed. We're not going to do that. We have plenty of time. We're learning relatively simple information. It's important, but it's not overly complex. And so I think it's going to be a great atmosphere and a nice semester. So I'm looking forward to it. Have a great day, and I'll see you a week from today because Thursday's class is online.